Go.
Hello!
Hello, Mr. Aaron, Mr. Ryan. How are you today?
Goody!
What have we talked about yesterday? Remember?
We talked about
The factorial
Oh
thing.
yeah, we talked about the factorial thing.
Okay, so can you remind me? Okay, so
And it's the factorial sum.
0 factorial equals what?
1.
1 factorial.
1 factorial equal 1.
2 factorial.
2,
3 factorial.
6,
4,
24,
5.
120.
Okay, and if I give you a number
6,
like
720.
okay, if I give you a number like 31, can you tell me whether it's possible to use the this
It's
thing?
impossible.
This thing. What's this thing mean?
Unique.
Unique. Okay, this thing unique. So for the 31, can we use this thing?
Yes.
And what are those?
1, 6, 24.
1 plus 6 plus 24. And how are we? What's our approach?
Okay,
to
so
do
we
this?
just replacing. So we are showing the one. Yeah, you like that. Which that 31 can subtract by, and then we are subtracting the biggest as possible.
So okay, 31 and then
24.
and then okay,
And then-
so we minus 24, which would give 7, and then
And minus 6.
yeah, 6, and then 1. We have 1. Okay, yeah, okay, but not here because there are 2 1s. We just need 1. Okay, and so what's the term complexity of this algorithm?
Let me try this one.
What's the term complexity for this one?
I think it's the you called it OM.
And what's M?
You're saying that like this bit.
Yes, the number of factorials, that distinct factorials that are smaller or equal than n, right? Okay, okay. So look, if we have this distinct factorial number, saying okay, this is the list of the numbers we have 1, 2, 6, 24, 120, and then 720. Okay, and then we have we know we are given a number like 144.
144.
So this is not like a knapsack problem. Okay, so these are the items. These are the weight of each item, and then
You
this
don't
is
need
yeah.
this one.
Yeah, I know, but yeah.
Too
And
heavy.
Too heavy. Yeah, you are right. Too heavy. So this is the capacity of the bag. Yeah, and this is the item for each. This is the item, the weight of the items. Yeah. So the question becomes that can we fill the bag, the knapsack,
Hey,
which with some of the items, yes, and we want to exactly fill the bag, right? Okay. Yeah. So for example, like, so if we list the items here, Eric, 1, 2, 6, 24, 120, and then for each item, how many choices do we have?
We have 5.
No. For example, I want to. This is item 1.
Yeah.
It's weight. It's weight 1 kilo, for example.
Mm-hmm.
And how many choices can we have, if we by deciding to put it into the knapsack?
2.
What are those items?
Pick it or not pick it.
Yeah, pick it or not pick it, and then we can use this strategy, right, to try each possibility. So for m items, what's the term complexity of this algorithm?
OM.
Nah? Oh wow. So
it's
wow. So and there are m items, and each one I can have pick or not.
M times 2. No. Wait. Am I close?
No, yeah, a little bit close, but not too.
Something with 2.
Yeah. What's
M to the power 2.
yeah. So no.
Oh no.
O to the power of.
No, O to the power of M.
Yeah, of course.
No.
Why is that? Look.
Oh, because we can have 2 choices with each note of M.
Yeah. So 2 times 2 times 2 times 2.
2
This
times
is
2.
the multiplication. Okay. Okay. So let's try this step for search. Okay. Let's try this step for search.
Look at my new tattoo.
Okay. Enough. Define let's say distinct sum. Okay, sum of factorial. Let's say factorial sum. And then we are given this n. The first thing is to do what?
The first thing is to place the.
To what? We are given this number n. So the first thing we need to do is find out what?
The fact.
The factorial that are smaller than or equal to n, right? And then where we're going to put it?
In fact.
And what's the fact?
Is the thing we
What's the fact? What's the data structure we are going to use to store the number of factorials?
we are going to put it in like a fact.
Yeah. What is that? What is this? What is this?
A list.
A list.
A
A list of
nums.
yeah. A list of numbers. Or we can use we can put it in the double NDQ. Yeah. DQ. We can also put it in double NQQ. Okay. So look. Factorial equals. Let's put it in the DQ. Yeah. DQ.
DQ. Double-ended Q.
Double-ended Q. We can put it in both sides. Okay. If we put it on the left, then there will be a descending order. Yeah. The biggest factorial will be on the beginning. Yeah. If we put it at the end, the biggest factorial number will be at the end, right?
Mm-hmm.
Okay. X equals 1. While what? Let's say. Let's do this. K. Okay. K equals 1. While k smaller equal n. What do we do now? Why k smaller equals n? Well, k times equals x. And what should we do now with k? K is the factorial.
X.
No? K is the
Oh yeah,
factorial.
K.
And what do we want to do? Put it in a what?
We put it in fact.
Fact. Yeah. Append left or append.
Left.
Yeah, let's put it in the left. So the leftmost, the first one will be the largest factorial. Append left. Okay, and then what should we do with the x? What should we do with the x?
We shall.
What should we do
add
with
equal 1.
Yeah,
Yes.
x add equals 1. Okay, so now the factorial will be the list of the factorials. List of factorial that are smaller than n, right? Okay, then now we do this DFS, DFS, and then. So what kind of parameters do we have here? So for each item, so if we have this array, factorial, this is the factorial, yeah, factorial. For example, like 144, yeah, that will be 1, 2, 6, 24, 120, yeah, that's it, yeah. A factorial will be actually it will be the opposite, right? Because we append left, so you'll be what? It will be the opposite. So you'll be 120, 24, 6 to
We didn't
1.
need to change 6.
Oh yeah, because it's in the middle. Okay. So
Slam
So-
bang in the middle.
n equals 144, right? So
Yeah.
at the beginning,
So you
at the beginning we try. So we need a index to point out to which value we are using, right? Okay.
Yeah.
So let's call it index.
Index finger.
And then the
Here's my
second
index finger.
parameter will be
Hey, you
n.
grew.
No. The second parameter
yes,
will
you
be
did.
n, right? N, right? This is the number of the capacity left in the bag. Am I right? Yeah.
Yeah.
So when it's reduced to 0, what does it mean?
It's true.
Yeah, it should means that we have found a way to fill the bag with all the with items. Yeah. So look, if n equals 0, return what?
True.
Okay, and then if n smaller than 0, what should we do? If it's smaller than 0, what does it mean? Return what?
False.
Yeah, because it's not possible, yeah. Okay, and then if index equal bigger or equal length fact, what does it mean? Return what? If the index here, if it's run out of index, if it's index here, what does it mean? That's 0, 1, 2, 3, 4. If it's equals to 5, what does it mean?
False.
Yeah, because we have tried every possibility. Yeah, we try each item. Yeah, and then can you tell me what's this? Return what? Return what?
Return.
So how many choice for this index? How many choice do we have?
Return if n equals 0.
No. What's the any zero here? Depth search what? For the index, current index. I try the next index. Try the next index, right? So
Index plus 1.
Index plus 1. Okay, so the next item I want to try is index plus 1. And so for this item, what can we do with this? Do we pick it or not pick it, right?
We can pick it or not pick it.
Okay,
Three
for pick it.
choices.
For pick it, what should we do with n? If we pick it, what should we do?
We shall subtract.
N subtract what?
The
Index thing.
yeah.
So what? Factorial index, right?
Yeah.
And then what should I put? O or n?
Or
This is pick, yeah? And the other one is not pick. So one of them is true, or both of them is true, are true. What's your opinion about this?
I think you're doing something like or.
Or, yeah, because yeah, you can pick or not pick, right? So that's all. Or what? Or what? Let's put it here. Depth search. Index what? Alright? Index what? Ryan, index what?
Index plus 1.
Okay, and then not pick. If you not pick, what happens with this n?
Or
No. With not pick, what happens to this n? If I don't pick with this, and how many items do? What's the weight left?
the weight is
Is what?
needs to be 0.
No. Currently is n. If I pick one item, then it subtract this.
Yeah.
If I don't pick this, do I need to subtract?
No.
So what's happened here?
N.
And it will be n, right? And then I just need to return, calling this function, return DFS, index will be 0, and then passing the n, right? Passing the n, look, yeah? Okay, so this is pick, this is not pick, and one of them is true. It means that we found a way, right? Am I right? Yeah?
No rubbing out.
No rubbing out, no rubbing out. So, does it make sense? Does it make sense? Does it make sense? Yeah. So, okay, I'm going to erase the last bit. Can you write it?
Oh, good.
Oh, God. Return what? You can just write it here. Yeah? Alright? Return what?
Return depth search.
Yeah, return depth search. We are calling the recursion, we're calling itself, yeah? Depth search.
X plus 1.
No, there's no x. Come on, it's different. Depth search what? Index. Yeah. Index means the
Plus
next one.
1.
Means that I want to try the next one. Yeah. And then if pick or not pick, n minus FACT. What?
Fact.
Yeah, bracket. No, bracket. Bracket, not curly. This is square bracket. Yeah. Square bracket to if we want to visit, if you want to get a value, yeah, and then index. Index what?
Index.
Index. Yeah, and then bracket. Okay, or yeah, the next one is or what?
Return
this is
0 n. Return bracket 0 column n. Closing bracket.
No. Why the return again? Return these. This is to pick, and then what's the other option?
You can.
Not pick, right?
Yeah.
So or yeah.
Depth search
Yeah.
0 n.
Not yet. He's not finished yet. Index plus 1, and then n. That's it. Yeah. And then we are calling with DFS what? What's the value of index at the beginning? What's this index?
0.
0. And what's the value of n? What's the value of n?
The value of n is the sum.
It's n. Come on, it's n, right? It's the same, yeah. Passing the n, right? Got it?
N is the n.
Yeah. This
N
n
is
thing.
an n. That's so obvious.
Yeah, that's not so obvious. Yeah, because we want to find out if we can sum up to n, right? And that's the weight of the knapsack, right? That's the maximum capacity of knapsack, okay? Okay, that's it for today. So, last thing, which one is more efficient? The one we talk about today or the one we talked about yesterday? Using the try the maximum thing. Which one? What happened? Yesterday the complexity is what?
O-M.
And today's complexity is O what? Come on, we talked about this before. Each one has two options. Yeah? Each one.
O2 to the power n.
Okay, so which one is better?
This one?
Yeah, of course, this one is far better than this one, yeah? Look, OM is here. And what's O to the power of n? 2 to the power of 0 is what? 1. 2 to the power of 1 is 2, so it will be like that. Okay? So this is M. This is the complexity, OM. Okay? OM is this line. Okay? OM. And O2M is this line. So 1M is 100. Yeah, M is 100. O2 to the power of 100. That's a very big number, right? Got it? Yeah, you see? So in this case, we can see yesterday's approach is far better than this one. Today we're using the recursion depth search. Yeah? Where is the recursion happening? Yeah, can you tell me? Recursion happening. What's recursion?
Recursion is like
What's recursion? Come on, we talked about it first day.
Okay, so recursion is like a thing that is how can I explain?
What? What's recursion mean? Can you give me an example?
Explain.
Okay, so can you point to me which are recursion calls? Come on, recursion.
Wait sec.
What's recursion? Recursion depth search.
Yeah.
Come on. Yes, recursion. Look, this is a function name we declare here. Recursion is calling itself, okay? Yeah? Calling itself, yeah? Yeah? Do you still remember how can we write a recursion function to calculate the factorial? Let's just give a quick review, yeah? Come on. That's the very basic. You shouldn't forget about it, okay?
I can't just explain.
Okay, then tell me. Factorial. Okay? F0 equals 1. F1 equals 1. F2 equals what? Factorial.
F2 equals 2.
2. Okay, F3 equals 6. Okay, Fn equals what? Equals n times what?
Times
F what?
Fn minus 1.
Yeah, that's it. So let's recursion. Look, Fn cost Fn minus 1. And we know the initial condition, right? So if we implement this using recursion, how can we write it? Just a little preview, okay? Review, okay? Define Fn if n equals 0 or n equals 1. Return what?
Return.
What?
If n equals 0 or n equals 1.
Return what?
True.
What's the factor return?
False.
No? What's the value of factorial? F0 factorial and 1 factorial. What's the return? Return the integer. What's that?
The integer is
What's the value of 0 factorial and 1 factorial? Come on.
1.
How high is that? Return what?
Return. Wait. Return.
I just tell you. Come on, that's recursion. I want to call this F. What's
F.
it? Yeah? F what?
Fn subtract 1 times F when I mean n.
Yeah, okay, so where is the recursion? This bit, yeah, recursion. That's recursion calling itself, okay? That's it. And you can put a cache here if you want, okay? Yeah, cache. Okay? Does it make sense?
Mm-hmm.
Okay, see you. That's it. Alright?
Bye.
Bye bye.